Have you ever wondered why a spinning top doesn't immediately fall over? Why it seems to defy gravity for a moment as if it's caught in a delicate dance with the forces of nature? Welcome to the fascinating world of physics, where we're about to unravel the mystery behind the gyroscopic effect. The gyroscopic effect, also known as gyroscopic stability, is a principle in physics that explains why spinning objects like a top or a bicycle wheel resist changes to their axis of rotation. It might seem like magic, but it's actually all about the laws of motion. Imagine a bicycle wheel spinning at high speed. The wheel wants to keep spinning in the same direction. This is due to a property known as angular momentum. Now, if a force is applied to try to change the direction of the wheel, something interesting happens. Instead of moving in the direction of the force, the wheel moves at a right angle to it. This is the gyroscopic effect in action. The key to understanding this lies in one of the fundamental laws of physics, Newton's third law, which states that for every action there's an equal and opposite reaction. When a force tries to change the direction of a spinning wheel, it's met with an equal and opposite force that keeps the wheel spinning. This opposing force is known as torque. Torque is the rotational equivalent of force. Just as force can cause an object to move, torque can cause an object to rotate. The faster an object spins, the more angular momentum it has, and the more torque it can produce to resist changes to its axis of rotation. So when a spinning top begins to tilt, the force of gravity tries to pull it down, but the top's angular momentum generates a torque that resists this force. This results in a phenomenon called precession, where the top appears to wobble around its base instead of falling over. In a nutshell, the gyroscopic effect is a fascinating demonstration of how spinning objects resist changes to their axis of rotation. It's a remarkable example of physics in action, showing how the laws of motion govern the world around us. Today, we've dived into the intriguing world of the gyroscopic effect, exploring how spinning objects like a top or a bicycle wheel resist changes to their axis of rotation. We've learned about angular momentum, the property that keeps these objects spinning, and torque, the force that resists changes to their direction. We've also seen how Newton's third law of motion underpins this phenomenon, with every action met by an equal and opposite reaction. So, the next time you see a top spinning or a bicycle wheel turning, remember the gyroscopic effect. Remember the delicate dance between forces that allows these objects to seemingly defy gravity. Because in the world of physics, there's always more than meets the eye.